I will try to derive the formula from plane ceiling and Mercator ceiling. But first, we will try to refresh our memory from the right triangle. So from point E to point B. Now, the direction looks like northeasterly. So since north going to north and since S going to S. Okay. So we will complete the right triangle. That's angle theta, of course. And of course, the opposite side, which we call it as angle A. And of course, the adjacent side, which we call it side B. And of course, the hypotenuse, which we will call it side C. Okay, so it is now a right triangle. Now, next slide. Our focus, our aim, our goal is about plane ceiling. So we will make it a plane ceiling. So instead of opposite, we will use the word departure. And instead of adjacent, we will use the word dilat. And instead of hypotenuse, we will change the word uh, into distance. Now it looks like familiar. We are on the familiar ground. Now enter the dragon, the plain sailing. It now looks plain sailing. And of course, the sukatua to derive the formula. From the so opposite, that's departure over hypotenuse, which is the distance. And of course, the ka, the adjacent, which is dilat over distance. And of course, the tua, which is opposite, which is departure over dilat. Okay, so to make it more easier, we will transpose the distance, which is distance is equals to dilat over cosine course. Okay, so that's the formula for plane sailing. So what is plane sailing anyway? Plane sailing is the navigation or conducting opposite by neglecting the Earth's curvature of the Earth as or part of it as a plane. Again, neglecting. So neglecting the Earth's curvature to make it as a part of it as a plane. Okay, the retro plane. Next, so what is the departure formula? This one. So departure formula can be calculated by the longitude 1 and longitude 2. Okay, so departure can be calculated by longitude 1 and longitude 2. As I promised, I will try to discuss or derive the formula for Mercator ceiling. So what is Mercator ceiling? Mercator ceiling is another method of drumline ceiling. It is used to find the course and distance between two positions that are different latitudes from the large dilat and distance. It is similar to plane ceiling except that the plane ceiling is used for small distance. So the difference between plane ceiling and Mercator ceiling is plane ceiling is for small distances, whereas Mercator ceiling is for large distances. Okay, so there you go. Since it is large distances and this is Mercator ceiling, so from plane ceiling extend, since this is large, extend, extend. So there you go. And then change the word departure into D-long and change the dilat into DMP and for the distance the same. Okay, so enter the dragon, the suka tua, the walang kamatayang suka tua, and then we can derive the formula for the Mercator ceiling. Okay, so here we go. For the ka cosine course adjacent, so adjacent is DMP, adjacent silingan DMP over hypotenuse, so distance. There you go. And then to make it easier, we will try to transpose. So transpose for the distance, distance is equals DMP over cosine course. And of course, yeah, for tangent course, so d long over d in p. So TUA, opposite over hypotenuse, so d long over d in p for adjacent. Okay, so these are the two known formula for Mercator selling. Okay, so formula is not too good if it is not used by using an example. So I will try to make an example. Okay, so somewhere in Bagakay Point to Palumpon Leyte. Okay, so this is point A and this is point B. Okay, so if you notice, the answer is already there. The course is 25 degrees and the distance is 43.2 nautical miles. Okay, so we will make the example into plane triangle. Okay. So if you notice, it is now in a triangle, and then the departure, we can solve it by using the longitude 1 and longitude 2. Likewise, the lat, we can solve it by using latitude 1 and latitude 2. The course is unknown, the distance is unknown. Okay, so we will try to answer it using the formula we have just derived a while ago. Okay, so here we go. So punch in the given number. This is the given, this is the known number, this is the given, this is the question, this is the formula we have just derived a while ago, and bring down the given numbers. Okay, so please take note that same name minus the parent name plus. Okay, so this one, this case, the bigger number is 1102 minus 1023. So 11 degrees 02 minutes minus, because why minus? Because same name minus, so minus uh, 10 degrees 23 minutes, so equals, boom, 39. So there you go, 39. Okay, next, bring down 39 because it's already minutes. So in longitude, the biggest, the larger number is 124.21. So 124 degrees 21 minutes minus 124 degrees 02 minutes equals. So there you go, 19. So the same answer, the same answer. Okay, so bring down 19 and then punch in the formula. The tangent course is equal to departure over d lat. So departure is 19. Okay, sorry. So 19 over uh, d lat is 39. So 39 over 19 over 39 is equals to is d. So 4871, 79, the same answer. So why northeast? Because latitude is north and longitude is east, so northeast. So why 25? Because tangent course. So this one is equals inverse tangent answer, and then close parenthesis equals, so there you go, 25.97. Why again northeast? Because latitude is north and longitude is east, so northeast. Now in the quadrantal azimuth, northeast is as east. Okay, so the course is 25.97. Okay, so if you notice on the a while ago on the previous pages, on the previous page, the answer is 25 degrees. Okay, next is distance. Distance is d lat over cosine course. So d lat over cosine course. So all clear. And then 39 over cosine course 2597, 25.97. Because it is course, it should be degrees, and then close parenthesis and cosine, yes, equals boom 43.38. So there you go. So the distance is 43.48. That's for plain sailing. So the same answer. The same answer. Plain sailing by a by a mathematical formula. Okay. Next slide. So in Mercator ceiling, there is that word meridional parts. So to make it easy, use the meridional parts calculator. I will teach you this one later. But first, the given problem is 1023. So punch in the 1023 and then calculate. And the meridional part is 622.2222. So we will use three digits only. So 622.222. Okay. And 1102 punch in, and there you go, calculate 661.653. Okay, so next slide gani. Okay, punch in the given numbers or the known numbers. So enter the meridional parts. So the meridional parts for 23 is 622.222, remember, and the 1102 is 661.653. Okay, so the answer is, but first, please remember same name minus different name plus. Okay, so latitude, we have solved this one before from plane ceiling. So the same, bring down 39, and then for DMP, say the bigger number is 661.653, 661.653 minus 622.222 equals 39.31, and boom, 39.31. So there you go. Okay, and the day long, we have answered it one, 19. So bring down 19, and then enter the formula. For the formula for the tangent course, so d long, all clear. D long is 19, and over DMP is 39.431. Okay, so 39.431 and equals, okay, 481 is 45785, and then tangent course, so inverse tangent, answer, close parenthesis, and boom. Okay, so the tangent course is 25.7. Why north? Again, because the latitude is north. Why east? Because the longitude is east. So almost the same, guys. So because it is on the quadrantal of northeast as east, so 25.73. Okay, so there you go. The same answer. Next is, no, not the same, not actually the same. The error is negligible, very negligible. Okay, so the distance is, enter the formula. The formula says DMP distance is equals to DMP over cosine course. Okay, so punch in the number. So 39.431 over cosine course. So cosine the course is 25.73, 25.73, because this is course, so it should be in degrees, and then close parenthesis, and then equals, and boom, oh yeah, there you go, 43.77. So the distance is 43.7. All right, so take note, 25 point, no, we will just take the whole number 25 and 43 and go back to the question problem. There you go, 25, 43, so almost the same. All right, so there you go. Thank you, people. I hope you learned something. Thank you. Goodbye.